Hello students, welcome back to Akshar ID Foundation classes. I am your chemistry faculty, S. Mohan. So students, we are doing 7th class, right? And in that we are doing chemistry, periodic properties. So, periodic properties. Periodic properties. And in the last class, we completed the synopsis 3, and today we start synopsis 4. Alright? What did we complete in the synopsis 3? Did you remember? In the synopsis 3, we discussed about the ionization potential, right? Ionization potential. So, ionization potential, once just recollect the amount of energy required to remove an electron from the outermost shell of a gaseous neutral atom is called ionization energy, right? Chalo. So, today we are going to discuss about the electron affinity. What is our topic? Electron affinity. Okay, what is electron affinity? Exactly opposite to the ionization potential. So, in the last class, what we discussed, ionization potential, the same thing, exactly opposite to the ionization energy or ionization potential is electron affinity. So, once again we recollect the definition, ionization potential. The minimum energy required to remove an electron from the gaseous neutral atom. Means, here I am writing, so see here now, here ionization energy what we discussed is, for example, there is one element M which is in the neutral at a gaseous state. Now, I want to remove one electron from this one, right? So, I apply some energy, right? I am writing E1, right? So that what happens is this one electron is removed, means one electron comes out, then it becomes M plus. Okay, so this is this E1 here, it is called the ionization potential. This is what we learned, right? So we are providing the energy, means what? Atom is taking the energy, observing the energy, and that losing one electron and becoming positively charged. Right? Now, exactly opposite to this one is what? Here we are applying the energy to take the electron. Now, for example, imagine this way: if you are giving an electron to the atom, if you are giving an electron to the atom, then what happens? Atom should give the energy. Yes. See, for example, you want to purchase one book. So, for example, you think you send a younger brother or sister to get one book. So, what she'll do? She go and she gives the money to the shopkeeper and she'll take the book, right? So, she is giving money and take the book, right? Now, she came to you and given to you. Now, when you see that book, imagine that what the book you are said to bring to your sister, this book is not that book. So then what you do? So you go to the shopkeeper, you give the book to him. So when you give the book to him, then what happens? He gives the money back to you, right? So imagine that here money is energy, book is electron. So here what's happening? You are providing the energy so that it is giving the electron. You are providing the energy, so it's giving the electron. Right? Now in the reverse case, here if we are giving the book to the shopkeeper, then shopkeeper should give the money to us. So if you are giving the electron, then atom should lose their energy. Correct? That is electron affinity. So today's our topic is exactly opposite to this one. Now, for example, there is one element called X. Okay, we take one element called the X. This is X. Okay, to this X, we are providing one electron. Yes. So when we provide the electron, now this X is neutral, means number of protons is equal to number of electrons, it's neutral. But you are providing one electron is negatively charged particle. So it takes electron, then it becomes what? X minus. Okay. And when it takes electron, what is it? It releases energy. Right? So here this energy is called the electron affinity. What is called? Electron affinity. So what I'll write? EA1 I'll write. Why 1? Because I'm providing the first electron to the atom. So it gives the energy. Is this clear? Any doubt? So now how can you define? Now once you open your material in the page number 86, there's a definition. The amount of energy released. See here definition, here definition. Here the amount of energy required we said. But here what we are saying, the amount of energy released. Okay. When an electron is added, there what we said here, when the amount of energy required to remove the electron we said. But here when electron is added to the valence shell of neutral isolated gaseous atom is called its electron affinity. Clear? So we are giving an electron so that it becomes in X minus, means negatively charged here, and releasing energy. So this is called the electron affinity. So when we add one electron, so now this is neutral atom, right? But when it takes an electron, it becomes a uni-negative. What it becomes? A uni-negative. Means what? One unit of negative charge is there on it. Right? Now, for example, this one I will take, okay, means this X minus uni-negative ion, and I would like to add one more electron. Okay. Now what happens? Okay. So here, this is neutral atom, so I'm giving one electron. So then what happens? Its atom is releasing the energy. So what is the amount of energy is released? That is called electron affinity. So electron is added, so it's releasing the energy. Now here I am taking this uni-negative ion. Again I want to add one electron. Now here also I am adding one electron to that. Now you say, does it releases energy? Come on. No. Now it do not releases energy, but we have to provide some energy. Means it needs energy. It requires energy to take the second electron. Now the question arises that why, sir? Here you said that when electron is added, then atom is releasing the energy. So here also if you add electron, then atom should release energy. Why it takes energy? So here the reason is that here atom is neutral. So we are adding one electron. When we are added electron, the number of electrons are increased. So it becomes a negatively charged. Right? Now if I would like to add one more electron to this, then which particle I am going to add? Negatively charged particle. And already this atom is which charge? Negative charge. You know that like charges repel, unlike charges attracts. So here it is negative charge. Again I would like to add the negatively charged particle only. Then what happens? Negative repel. So this don't accept to take that electron. That will not accept to take that electron. Okay. So now we have to give forcibly to that electron. Right. So that's what here we need to apply some energy to overcome the repulsion force. Is this clear? So that is about the electron affinity 2. So now what happens? X minus 2. But here what is it? Plus EA written, no? But here I should write minus EA2. Here plus means what? Here it is releasing the energy. It's releasing the energy. but it do not releases energy, it absorbs energy. Why? Because already when electron is added, it becomes negatively charged. One more electron if you would like to add, so negative, negative, repel. So there is a repulsion force between this and this electron. So now to overcome the repulsion forces, we need to provide the energy. Is this clear? That's it. Now come to the units. What are the units? What are the units for the ionization energy? This also same units. Okay, kilocalories per mole, kilojoules per mole, or electron volt. Whatever the, because this also energy, that's also energy. Exactly opposite side, right? So here units are electron volt EV or kilocalorie per mole or kilojoule per mole. Okay, so these are the units to this one. Okay, sure. Now let us come to the next one is the factors. What are the factors on which this electron affinity depends? Electron affinity is energy only, again I said you similar to ionization energy. So it depends on the same factors like ionization energy depends. Ionization energy depends. What are the factors once you recollect? Atomic size, right? Atomic size, atomic radius. So here also atomic size is one of the factors. So I'll write here atomic size or atomic radius, anything you can write. Okay. And next is screening or shielding effect also we discussed, yes or no? Okay. So screening effect, or we can say the shielding effect also. Third one is what we can also discuss, like what we discussed more, stability of an atom. Right. So these are the some of the factors on which electron affinity depends. Atomic radius. So atomic radius is inversely proportional to the electron affinity. Inversely proportional to means what? As the atomic size increases, electron affinity decreases. Can you say why? See, here for example, let us take two atoms. One is I'll take fluorine and second I'll take chlorine. Okay. So here, can you see here? Okay, here I'll write that. Okay. Now, for example, if I take fluorine, what is the atomic number of fluorine? 9. What is the electronic configuration? 2, 7. Right? So, what is its structure? This is a nucleus. This is the first shell. This is the second shell. Right? Now, let us take the chlorine. Chlorine atomic number is what? 17. What we can write? 287. Now, what will be its structure? Your structure is nucleus. This is the first shell. This is the second shell. Now, it is the third shell. 3 shells on it, right? Now, here you see now. Here, first shell 2 electrons and second shell 7 electrons. So, I'll write 1, 2, 3, 4, 5, 6, 7. And here you see 2, 8, 7. So 2, next 8, 1, 2, 3, 4, 5, 6, 7, 8. Next 7. So 1, 2, 3, 4, 5, 6, 7. Right. Now, if I would like to add one electron here, okay, one electron here. So when I would like to add one electron here, see, for example, I would like to add electron here, then what happens? See, the distance between these two is very less. Yes or no? See, very less. So because the atomic radius, okay, the radius is very less. But here you see, if you like to add here, okay, now you see the distance is more because the size is more. Yes or no? The size is more, so the distance between two electrons is more. If the size is less, the distance between two electrons is less. If the distance between two electrons is less, means what? This is negative charge, this is negative charge. They are very close to each other, then what happens? Repulsion force will be more. Right? Repulsion force will be more. So we need to apply, we have to give more energy. Right? Okay. So here repulsion force will be more, so more energy. So therefore, as the atomic size increases, electron affinity decreases, right? So electron affinity is inversely proportional to, or atomic radius is inversely proportional to electron affinity. And screening effect, as the screening effect increases, screening effect means what? This also we discussed. As the number of shells increases, okay, so the nuclear force of attraction over the electron will decreases. This also we discussed. So this is also inversely proportional to electron affinity, right? And stability. Stability means what? Generally, the atoms of half-filled orbitals or full-filled orbitals. For example, take the helium, neon, argon, krypton, xenon. These are all the inert gases, noble gases, right? These are very stable. And they don't take any electron, they don't give the any electron, right? So, they require a very large amount of energy to take the electron or to give the electron. So, that's what these are the special conditions, okay? So, they require very large amount of energy is required, okay? So, that's all. Now, come to the some applications of electron affinity. Achha, how, let us see how it changes in a period and in a group. Now in the periodic table, if you see, okay, the periodic table, if you see, periodic table, we already discussed periodic table. There are periods and groups are there. What are the periods? Horizontal rows are called as a periods and vertical columns are called as a groups, okay. So how it will be changes in a period and a group, period and in a group. Okay, so here as we move from left to right in a period, electron affinity will be increases. Electron affinity EA, electron affinity increases. Now, why the reason can say, try to think why the electron affinity increases? Because as we move from left to right, we discussed that in the period, atomic size decreases. Yes or no? Atomic size decreases. So, atomic size is inversely proportional to the electron affinity. So, as atomic radius decreases, ionization energy increases because these both are inversely proportional to each other, right? So, therefore, ionization energy increases. If they ask you what the reason, the same reason you say, as you are moving from left to right, the atomic size of the atom will be decreases and electron affinity increases. So now you can say the group. Okay, the group what happens? Electron affinity will be decreases. Why electron affinity decreases? As we move from top to the bottom, the atomic radius increases. Why? Because the number of extra shells will be added. Just not fluorine and chlorine every time. Chlorine has 2 shells, and fluorine has 2 shells, and chlorine has 3 shells. So as you are moving from top to the bottom, what's happening? The atomic size is increasing. As the atomic size increases, inversely proportional, electron affinity will be decreases. Right? So these are the trends of electron affinity in a period and in a group. Right? So here one more small introduction of electronegativity is also there. Electronegativity means the tendency of a bonded atom to attract the shared pair of electrons. So this is also same thing, okay. When an atom attracts the shared pair of electrons, so it's attracting the electron, it becomes a negatively charged. So that's also called electronegativity, okay. Chalo. So, with this we completed this topic, and some practice sheet you can see here. Come, let's explore. Some practice sheet is there. So let's do this practice sheet, okay. What are the question first ones here? The energy released when a neutral gaseous atom takes up an electron. So when atom takes up electron, energy released. What it is called? Electron affinity. What is the answer? Electron affinity, right? Now second one, which among the following processes are exothermic? Exothermic means what? Which releases the energy. Endothermic means what? Which absorbs the energy. So here it is releasing the energy. So this is an exothermic process. So option is 1. Which of the following has a zero electron affinity? Zero. Which will not take the electron? Just now I told you that inert gases are stable and their outermost shell is filled with 8 electrons except the helium. So they don't take any electrons, they don't give any electrons. So electron affinity for the inert gases is 0. But here what is given? Oxygen, fluorine, neon. Neon is the inert gas, so answer is neon. Next, on moving from left to right in a period, in a period, electron affinity what happens? Increases. So option is 2. Okay. The element with the highest electron affinity, remember, so that is chlorine. You have to remember this one. So that is highest electron affinity element is chlorine. Okay. So option is 3. The units of electron affinity are what? Just now we give electron volts, kilocalories per mole, kilojoules per mole. In this, what is given? First one is given, kilocalories per mole. So the first option is the right answer. Seventh one you see now. Energy is absorbed. Energy is absorbed when a second electron is added. Just now I told you that yes, when the second electron, already when the first electron is added, becomes uninegative. One more electron is added, so then what happens? It releases it absorbs the energy now. Okay. So energy is absorbed when a second electron is added to this is because O minus has a stable egg, no. Oxygen atom is repulsion with no, yeah. Okay. So oxygen has a repulsion. I told you no. So the electron already negative charge is there. One more electron is added, so this becomes what? Okay, like charges repel. So negative to negative. So repulsion charge. But here instead of O has a repulsion charge, O minus you have to write. So the question might be printed wrong. So in the 2, just O minus you write. Okay. Now, which of the following process involves the release of energy? So chlorine, oxygen, nitrogen, which of the following involves in the release of energy? So here out of these 3 better we take the N2. Okay. Why N2? Because nitrogen atomic number is 7, but 2 minus is given means already it has taken 2 electrons. So nitrogen when it is taken 2 electrons, 7 plus 2, 9 electron. So it just 1 electron is required to attain the stability. Okay. So it should have 8 electrons here. Nitrogen, what is the nitrogen atomic number? 7. So here N minus 2 is given. Minus means what? Minus 2 means what? The nitrogen is taken 2 electrons. So and 2 electrons, 7 plus 2 total becomes 9 electrons. If you write the electronic configuration of 9, what we write with 2 comma 7. So here outermost orbital has 1 electrons, only 7. It requires just 1 electron to attain the stability. So it's easy to take the 1 electron to attain the stability. So here the option is third option. Okay. Ninth one, the electron affinity of K plus ion is numerically equal to. This is logical question. E of chlorine atom, no. E of chlorine, no. I of argon atom, no. I of potassium, yes. Yes, I of potassium atom. Why I of potassium? Ionization energy of potassium atom is what? I means what? Ionization energy. Ionization energy of potassium atom is what? The energy required to remove the electron. So we are applying some energy to remove the electron so that it becomes K plus. Again to become a K, okay, then we have to give the electron to that. When you give the electron, how much energy it is taken, the same amount of energy releases. Just how I told you, if you take one book, purchase the book of cost of 100 rupees, okay, again you are giving the book to shopkeeper that you don't want, he will give you 100 rupees, same no. So here electron affinity of potassium ion is equal to ionization energy of a potassium atom. Remember this one. And your electronegativity values of halogens. Halogens means what? Seventh group elements like fluorine, bromine, iodine. These are called as halogens, right? So here X, Y, Z are respectively minus 349, minus 333, and minus 325. Then X, Y, Z are respectively here. Fluorine, bromine, bromine, bromine. So here, see students here. Here just now I told you that which is the highest electron affinity element. The atom with highest electron affinity is chlorine, I said, right? So here you see 349, 333, 325. So in this highest number is what? 349. So 349 is what? Chlorine. So chlorine, fluorine and bromine. So the option is the second option. Okay. So with this we stop today. So you can remaining you can try it, because these all are theoretical questions. They are not like a mathematical or solving problem, something like that. So read the theory part concept perfectly and then try to solve this exercise 1. Okay. So today with this we stop, students, and so with this this topic means periodic properties is also finished. Periodic properties, we have only 4 synopsis here, and next some more synopsis also are there, continuous to this one, that you will learn in the higher classes. Means you are in 7th class, now you will be learning in the 8th class. Okay. So the same chapters will be repeating for 6th, 7th, 8th, 9th, 10th. But as you are going the class wise, you are entering into the very depth knowledge. Okay. So by completing the 10th class, the meaning is what? You are ready to like you know everything, like intermediate level syllabus, like 12th standard syllabus to you. Okay. So that then it becomes very, very easy to you. So to write mains, actual mains, JEE, okay, and advanced. Okay. Chalo. So with this we stop, and we have one more chapter after this one. That's the last chapter for second volume. That is, I think, mole concept, right? So this mole concept will start in the next class. Okay. Bye. Take care.